minute break on the timer. So I'll give you an introduction now in 4 minutes and see. Okay, so let's go to the whiteboard. Okay, so you know what? The kidney development is a little complicated because, normally you only get one heart, right? Like during pregnancy, the development of the baby, you just get one heart and that's it. But unfortunately, the kidney development is a little complicated because you get 3 kidneys, right? Depending on the stage of the pregnancy, you actually get different kidney according to the pregnancy stage. So in the beginning, you get a structure called a pronephros, which is, one kidney, and then the mesonephros and the metanephros. Forget about the names. I don't care about the name. I just care about the idea here, okay? So we have 3 structures. Like I said, guys, the kidney is a very simple structure. So what is the kidney formed of, or what is the main composition of the kidney? What does the kidney consist of? As simple as that, the kidney is 2 things. It's blood vessels, right, that filter into tubes, right? That filter in tubes. That's the kidney. I want you to think about the kidney this way, right? Just some blood vessels that filter into tubes. So in the beginning, during pregnancy, the body makes 2 types of kidneys, okay? Or two kidneys, actually, before it makes the final kidney, which is the 3rd kidney, okay? So you might think, okay, so what is the structure of the 2 kidneys that eventually, degenerate? So the body gets rid of the first 2 kidneys, just, as a stage of transition into the final kidney, okay? So the kidney, the body makes 2 kidneys, right? The first kidney, the second kidney, and then these guys degenerate, and the 3rd one is what remains. And if you want to think about it, the simplest way possible, the first kidney and the second kidney, they are as simple as some blood vessels, right, that looks like a glomerulus that filter the blood into some tubes, okay? And please, guys, I want you to think about this, okay? So when I say the word pronephros, because this is going to come into play here, the word pronephros, let's break it down. The word pro means before in Greek or Latin or whatever, right? It means before. So this is the first kidney that's developed. And the pronephros is basically some blood vessels that drain into tubes. That's as simple as it gets, guys. Okay? And you have to know that this tubule has to drain into a bigger tubule to eventually drain into the bladder, right? So you have to know that there is a 3rd tube, it's called the nephric duct that takes the tube, the urine from these tubes, right? And drain it into the bladder, right? So that's as simple as it gets. The word pronephros, pro means before, nephros is kidney, so this is the first kidney, right? It's before everything, the first kidney that's created. Some blood vessels drain into tubes, the tube drain into nephric duct, which drain finally into the primitive bladder, which is not really a bladder yet. It's just something called cloaca, okay? Without too much names here, okay? And then finally, you get the final kidney after you degenerate these, right? You completely get rid of these 2 kidneys, the pronephros and the mesonephros. And the word meso, or the prefix meso, means middle, something in the middle, okay? So this is the middle kidney. So it's actually middle in 2 ways. It's middle because it's middle in time, like because it's between pronephros and metanephros. Meta means developed or fully developed or something after. Actually, the word or the prefix meta means after. Okay, so metanephros is the 3rd kidney, and this is the final kidney that the body actually develops into the fully developed kidney, the adult kidney. Okay, so the body basically gets rid of the pronephros and the mesonephros. Okay, and finally it gets to the metanephros. So that's just a simple introduction so that you understand exactly how the kidney development works until we get into the the fancy stuff. So I'll give you guys 10 minutes, and please be here on time. Exactly 10 minutes timer, and I'll just start right away because there is no much time. We started a little late today. So 10 minutes on the stopwatch, and here it is. And I'll start. So go drink some water, coffee, whatever you want.
How can I find the chat?
I think there is on the slide, you could see ask a question. You could send ask a question.
Okay, got it.
Okay, guys, let's recap what we just said regarding the kidney development. So it would be cool if the kidney directly is developed as it is in adults, but that does not happen. Instead, the body makes 2 preliminary structures that function as a kidney first, and then these guys degenerate, and the 3rd one is what turns into the real kidney. The two preliminary kidneys are pronephros. The word pro means before, pro before. The meso means middle, which is the middle kidney, and both these guys degenerate. And if you want to think about it, what is the definition of pronephros and mesonephros? Simply put, some blood vessels filter into small tubules that filter into bigger tube. Okay, eventually into the bladder. That's it. That's as simple as it gets. Okay, go ahead and solve this question, guys. That's a little bit of critical thinking here. I'll explain it, don't worry. Okay, 2 people answered. Okay, let's see the answers. Okay, so this is the arrangement, basically. All right, let's go back to the whiteboard so that everything makes sense. So remember, we said that these kidneys are simply blood vessels and tubules. But I didn't say where do these people originate from, right? Where do these blood vessels and tubules originate from? And simply put, all the kidney structures come from mesoderm, okay? If you guys remember, let's go back a little bit in time to talk about general embryology. So in the beginning, we have a zygote, right? We have a sperm, we have an egg. These two form the zygote, right? And then cleavage happened to create different, cells, eventually called the memorial and blastocyst, etc., etc. And eventually, the blastocyst is simply the surrounding trophoblast and the inner cell mass, right? The cytotrophoblast and trophoblast, this is like the placenta. This is going to be the placenta later. And this inner mass is going to be the baby, right? This is the fetus. So this inner mass actually divides into 2 layers. First one is epiblast, and the second one is the hypoblast. So it's like arrangement of the cell. Epiblast, hypoblast. And eventually, there is a process called gastrulation. Gastrulation is the migration of the epiblastic cells in the middle to form the mesoderm. So instead of being epiblast and hypoblast, they are ectoderm, mesoderm, and endoderm. This is basically the 3 layers of the baby that make different structures. For example, the ectoderm is going to make the skin, hair, nails, teeth, the nervous system. The mesoderm is going to make the blood vessels, the bone, the muscles, all the connective tissue. And the endoderm is going to make the hind gut, mid gut, foregut, which is the digestive system, and the bladder and stuff like that. So mainly the renal system arises from the mesoderm. That's high yield to know. There is actually like a question in New World that tells you, okay, where do you get the kidneys from? Mesoderm. Okay, specifically intermediate mesoderm. Forget about the name, but just know it's mesoderm. Okay, you'll get the question right this way. So the kidneys, which is, like I said, some blood vessels drain into tubes. Both of these guys arise from the mesoderm. Okay, let's go back to the question. So the first step is mesoderm makes simple vessels filter into tubes. Like we said, it's pronephros, mesonephros, which these guys eventually die out, right? And then mesoderm still makes the third kidney. The third kidney is a little complicated. We'll talk about it, but it's formed of two different structures. It's called metanephric blastema and the ureteric bud. Okay, we'll talk about that right now. Don't worry. The third layer, or the third stage or step, blastema, or the metanephric blastema, and the ureteric bud, they both interact together in order to fuse and make the kidney. Okay, I'll explain this. Don't worry, I'll have some pictures here to explain it. So let's go very slowly here. This is the embryo. This is like about 8th week, I think 7th week, something like that, or 6th week even. So as you see here, this is the gut. So this is supposed to become the digestive system. This is the kidney, okay? As you see here, it's in the cervical region actually, which is so weird, okay? So basically the pronephros, or the blood vessels that drain into the tubes, they're formed of something called the nephrogenic cord. So if you take a cut section like that and took a look at the back of the embryo here, this is the back, this is the front of the embryo. This is the nephrogenic cord. I know it's going to be a little complicated here. Just be patient a little bit and I'll explain everything. Nephrogenic cord is just accumulation of the mesoderm to form a structure that's called nephrogenic cord. That's very simple, okay? Just some mesodermal cells that collect together, they form a circle that's called nephrogenic cord. Okay, and then you have some mesodermal cells that form something called the mesonephric duct, which is basically, it's going to be the ureter and the end of the nephron, basically, right? It's the tubes that I'm talking about. Okay, it's that long tube. So remember, I said we have small blood vessels that filter in tubule, and the tubule drain into long tube. This long tube is the mesonephric duct, this one right here. Okay, can you imagine now? So this one is formed, this part right here is formed of the nephrogenic cord, and this one right here is formed by the mesonephric duct. Okay, let's go back. So this is a cut section again. This is the mesoderm. The mesoderm gives rise to nephrogenic cord, which is simply mesodermal cells that look like a circle. And then you have the mesonephric duct, which also, a tube-like structure. Take a look at C, this diagram here. What happens? The mesonephric tubule, which is this right here, becomes a little thickened, right? Which is going to make the tubules of the kidney, remember, right? We said this area right here, it's formed of the nephrogenic cord. Can you see these tubes, these small tubes, the small tubes? This is this right here, the mesonephric tubule. And the mesonephric duct, which is the long one, is going to be this one right here. I'm going to explain it a little bit better, don't worry. Just try to bear with me a little bit, okay? Remember, it's certain blood vessels. Can you see here? This is the aorta of the baby. It gives off, it's supposed to be the afferent and efferent arteriole, right? It drains into tubes, which is, it's going to be the Bowman's capsule, the proximal convoluted tubule, everything, until it gives off, finally, this is like the future ureter, right? The mesonephric duct, and a little part of the calyx, the calyces in the renal pelvis. Okay, I'll show you some pictures right now, don't worry. Okay, just focus with me a little bit. So some blood vessels drain into tubes that drain into a big tube. Okay, that's basically the basic structure. That's actually the developed kidney that I'm talking about. We forget about the pronephros and mesonephros. We already degenerated that. We have a different structure now, right? A more developed one. So again, the nephrogenic cord arises from the mesoderm, and then you have the mesonephric duct, right? This is going to form the tubules of the kidney, the distal tubules, and the nephrogenic cord is going to form the blood vessels and the tubes, right? The beginning of the tube, like the proximal convoluted tubule until the distal convoluted tubule. This is another picture, like from the anterior of the baby. So this is like the nephrogenic cord right here, and this is the tubules, right? I think that makes sense now. So this is like the long tubules, and these are small tubes that arise from it, which is what we draw here, right? So small tubules, they have small blood vessels, not drawn here, but obviously small blood vessels that drain into small tubules that eventually drain into the mesonephric duct, which will eventually drain into the cloaca, or the primitive urinary bladder. Okay, let's go back. Let's repeat everything we just said. We said that we have pronephros, as you see here, small blood vessels draining into tube, right? And then we have the mesonephros, which is some blood vessels that drain into tubes. These two guys degenerate, right? As you see here, degenerating pronephros, degenerating mesonephros. And then finally, what do you have? You have nephrogenic cord. Remember this guy that we talked about that came from the mesoderm, which is, circular structure. So the nephrogenic cord is going to form a structure, and this is step one stuff, okay? This is UWorld stuff. Nephrogenic cord is going to form the metanephric mesenchyme, or the metanephric blastema, okay? Metanephric mesenchyme. The word mesenchyme means connective tissue cell, right? But it's not a connective tissue cell, it's a primitive connective tissue cell. So actually, any connective tissue, for example, fibroblast. A fibroblast comes from mesenchymal tissue, which is the primitive or the embryonic tissue, the embryonic connective tissue, in other words, okay? So the metanephric mesenchyme basically forms from the nephrogenic cord, okay? And then what happens? Can you see this little diverticulum here? It's called the ureteric bud. And remember, let me draw this again to make this ultra clear to you guys. I know it's kind of hard, and renal embryology is a lot complicated, like very complicated, so don't worry. Let's go back. So we said small blood vessels that drain into some tubules that drain into big tubule, right? This big tubule is what gives the ureteric bud, okay? Because this one is going to degenerate, the other ones are also going to degenerate, okay? And you'll only have the nephrogenic cord that goes and interacts with the ureteric bud, which is just a diverticulum that comes out of the tubule, or the nephric duct, or the mesonephric duct, okay? All right, so I want you to imagine something. So the nephrogenic cord, or the metanephric blastema, is going to form a part of the nephron, and the ureteric bud is going to form the other part of the nephron, okay? Take a look at this picture right here. This is the ureteric bud. This is the metanephric blastemal cap, okay? Can you see the development? So the metanephric blastema, can you see this? What is going to happen, right? The metanephric blastema actually gave rise to, see, first of all, the blood vessel, the efferent and afferent. It gives rise to the glomerulus itself, the PCT, the loop of Henle, and the DCT. All that comes from this small metanephric blastemal cap. Okay. On the other hand, the ureteric bud actually makes the collecting duct, which drains into the renal calyces, the renal pelvis, and into the bladder. Can you guys see the difference? Okay, I'm going to stop here because I know this is so confusing. You guys can ask me any question right now. You have to get this very well. Like, you could ask me any question right now. What feels confusing here? This is a high yield topic. You like, MB means your world, everything. So they like to ask you about the origin of the glomerulus and the tubules, and the origin of the collecting duct and the renal calyces and the renal pelvis. They like to ask you about this. So, for example, an MCQ or a question could say, oh, what does the metanephric blastema gives rise to in the kidney? So the answer is glomerulus, proximal convoluted tubule, distal convoluted tubule, and the loop of Henle, right? This is metanephric blastema, which came from the mesenchyme, which came from the mesoderm. What about the collecting duct and the renal pelvis and the renal calyces? How do these guys form? They come from this small diverticulum, which is called the ureteric bud. Where does this come from? From this nephric duct right here, or the mesonephric duct. Okay. I don't see any question, so I'll just move on until you guys have a question or something. Okay, this is another picture to actually like determine what I'm just saying. Okay, can you guys see this kidney? So this is the renal calyces. This is the renal pelvis, and this is the ureter. It's purple because it came from the ureteric bud, which is this right here, right? So everything in purple came from the ureteric bud, and anything in pink came from the metanephric blastema. As you see here, the collecting ducts also came from the ureteric bud, but all the other tubules, including the glomerulus and the blood vessels, they came from the pink part here, which is the outer part of the kidney. I know it's it's very complicated. Kidney embryology is one of the worst topics in embryology, so yeah, just know this once and forever. It's very simple. The kidney structure is very simple. Some tubules that get blood vessels, that's all. Okay, there is a question here. When all this change happened, which trimester? Okay, this is actually important. So pronephros and mesonephros, they happen in about the 4th week to the 6th week. And then at, I think, the 12th week is when the metanephric blastema, thing happens, and then you get the ureteric bud. So in about the 4th week, so you get these degenerating pronephros and degenerating mesonephros. But I don't really care about these details. I just need to take care of the big picture here. I don't care about the details, which trimester, which whatever. It's not even a question on the test, right? They don't care. They care about you getting the idea. How does the kidney develop? The kidney is 2 parts, actually. As you see here, the renal calyces, the renal pelvis, and the ureter, which come to fuse with the nephron, the beginnings of the nephron, which is the glomerulus, proximal convoluted tubule, loop of Henle, distal convoluted tubule, right? So as if there are 2 structures that come together to form the kidney, right? One that comes from the metanephric mesenchyme, and the other comes from the ureteric bud. I hope that makes sense, guys. I have a lot of questions for you to make sure that you got it, so I'll see if you guys can solve all these questions, okay? All the other questions are just embryology, so I want to make sure that you guys get this. Okay, so again, the word, prefix pro means before. Meso means middle. Meta means after. The first 2 degenerate, which is the pronephros and mesonephros. The first 2 degenerate, and the third one condenses, which is the nephrogenic cord, to form the metanephric blastema. And then you have the ureteric bud arise from the mesonephric duct right here. Okay, and these 2, the metanephric mesenchyme and the ureteric bud, they fuse together to form the future kidney or the adult kidney. Okay, I hope you got that, guys. Okay, again and again and again, the adult kidney or the metanephros is 2 things: nephrogenic cord, which forms the metanephric blastema, which forms the glomeruli and the rest of the nephron until the DCT, or the distal convoluted tubule. And then you have the mesonephric duct, which gives rise to the ureteric bud, which gives rise to collecting duct, calyces, and renal pelvis. Sorry, this is not an X, this is an S. Okay. Let's see, guys. This is these are the questions. Let's see if you guys can solve this. Okay. Let's see. Excellent. Good job, guys. Actually, the mesoderm gives rise to every part of the kidney. Everything, right? The blood vessels, the tubules, the collecting duct, everything. Okay. This is another picture to remind you that the kidney is 2 parts. The tubules and the nephron, right? And this is the metanephric blastema, which gives fuse with the ureteric bud that comes from the mesonephric duct. And this from the glomerulus up to the distal convoluted tubule. Okay, go ahead and solve this question. Okay, people answered here. Okay, all right, guys. Let me explain to you why this answer is incorrect. Okay, so let me get the whiteboard quickly. In this question, I'm talking about the early stage, the earliest stage, okay? I'm talking about, okay, we have the nephrogenic cord right here. The first interaction between the nephrogenic cord, before it even gives rise to metanephric blastema, is the interaction between the nephrogenic cord and the mesonephric duct itself. And then what happens next is that the nephrogenic cord becomes the metanephric blastema, and then the mesonephric duct gives rise to the ureteric bud. Can you see the difference now? So let's go back. Nephrogenic cord gives rise to the metanephric blastema, and the mesonephric duct gives rise to the ureteric bud. And these two fuse together eventually, right? So the metanephric blastema is a little more developed than the mesonephric duct, okay? So the metanephric blastema does not fuse with the mesonephric duct. It fuses from something that comes out of the mesonephric duct, which is the ureteric bud, okay? All right, so again, pronephros, mesonephros degenerate, and then you have the metanephros eventually condenses to become metanephric blastema. As you guys see here, this is the nephrogenic chordal cells, right? This is the nephrogenic vesicle. Forget about the names, just these cells condense to eventually become this, right? The glomerulus and the early tubules, right? The PCT, the loop of Henle, DCT, until the DCT eventually. And then the other ones come from the ureteric bud. This is the ureteric bud, okay? Again, the ureteric bud arises from the mesonephric duct and interacts with the metanephric blastema, okay? Another picture, guys, to remind you, okay? Starting from the glomerulus up till the distal convoluted tubule, this is formed by the metanephric blastema. And that this area right here comes from the ureteric bud, okay? That comes from the mesonephric duct. Sorry, I know this is so complicated, but when you got it, you'll never forget it, okay? That's why I kept explaining it. Again, the interaction between two structures leading to their union. Here's the ureteric bud. Here's the metanephric blastema. They collect together, they fuse until you have the Bowman's capsule and the glomerulus up until the distal convoluted tubule. This blue color comes from the metanephric blastema, and this yellow color comes from the ureteric bud. Okay, that's so high yield, guys. I can't emphasize enough. You'll see a lot of questions about that. Okay, so thank God we have finished renal embryology. Let's make sure you guys got it in your pocket. Let's see some definition to see if you really understood the subject. As simple as it gets, guys. I know there is 25 letters, but you could actually answer 3. You could put 3 inputs. So. Okay. Derived from nephrogenic, meso-middle, gives rise to pro first, developed for weak. Okay. See a lot of answers, but yeah. Okay. Again, guys, the answer I was looking for is the word pronephros is the earliest kidney. So it means simply small blood vessels that filter into small tubules. You have to remember that. Mesonephros, same thing. Small blood vessels that drain to small tubules. These are the preliminary kidney. This is the simplest form of a kidney created by the human body, okay? The other one that you guys just wrote here, you wrote metanephric blastema. This is actually the developed one. And this is just the first part, which is going to create the glomerulus until the DCT, okay? Let's see the next one. Okay, there are only 3 students answered. What about the other 3? Okay, excellent. Function during early pregnancy for filtration of blood and then degenerate. Good job. Okay, let's see next one. Okay, forget it. Don't just write anything. I'll just explain it myself. So what is the metanephric blastema? This is basically came from the mesoderm that gives rise to the nephrogenic cord, which is simply some mesodermal cells that, form a circle that looks like a cord. Really, that's what nephrogenic cord means. And then the nephrogenic cord gives rise to, condenses the nephrogenic cord, which is this tall. It condenses and forms the metanephric blastema. And then the mesonephric duct gives rise to the ureteric bud, and both of them fuse together in order to make the kidney, the adult kidney. Okay, question 19. Final kidney is made by the fusion of 2 things. What are they? Okay, let's see the answer. Good job. Ureteric bud and metanephric blastema. Excellent. Good job, guys. Okay, question 20. We have 6 questions left. Guys, these are UWorld questions, okay? This is so high yield. Okay, let's see what you guys have answered. All right. Excellent. Good job. Great job. Great job. Okay, question 21. Okay, let's see the answers. Ureteric bud. Somebody picked both. So No, the metanephric blastema, like I said, it gives rise to glomerulus, proximal convoluted tubule, loop of Henle descending and ascending, and then the distal convoluted tubule. It stops at the distal convoluted tubule. And then the ureteric buds start by making the collecting duct, renal calyces, and the renal pelvis. Okay, question 22. Yeah, that's so cool. If you guys solved that, that's nice. That means that you guys got it. Okay, everyone picked. Okay, yeah, that's actually a trick one. Mesonephric duct is the same as Wolffian duct, and this is high yield because you would like to get the word Wolffian duct, just to confuse you, just out of nowhere, like to confuse you, okay? So the mesonephric duct is the same as Wolffian duct, okay? And the mesonephric duct, as you know, it gives rise to the ureteric bud. So actually both are the same. But you guys picked the correct answer. It's mesonephric duct for sure. Okay, question 23. So let's go to the whiteboard quickly so that I can show you something. So like I told you, this is the mesonephric duct, right, that we talked about. It gives rise to the pronephros, the mesonephros, and eventually the ureteric bud, right? So the interesting thing about this is that all this degenerate, right? But eventually the mesonephric duct, in addition to creating the ureteric bud, it also goes and create some other reproductive structures, right? So it goes to create the vas, it's a duct, right? It's a tube. So it could create other tubes like the vas deferens, the epididymis, okay? So the epididymis and the vas deferens are also formed by the Wolffian duct. And the way I remember it, the word wolf, wolf is like a masculine animal. So it makes sense that it forms the male epididymis and vas deferens. On the other hand, you have another duct that's called the Mullerian duct. Mullerian duct is a female duct that forms, the uterus, the vagina, etc. So you have to differentiate between the two. So let's see what you guys answered. Okay, good job. So some people, it doesn't degenerate completely. Some of it degenerates and the other continue to form the male